Hello Internet and fellow network engineers. My name is Maxim. I share network design ideas, tips and tricks with you on my channel. This video is the second out of 3 dedicated to Source Network Address Translation, or NAT. Do you actually know that private addressing can not only be a hassle, but also can be a security-focused design choice, following which certain networks and devices can be made hidden or invisible from the public internet? The second video is focusing medium-scale Source NAT solutions, which can be found in campus networks, small data centers, high-foot traffic locations. Hardware in my demo and designs is represented by Juniper SRX series firewall, which is available in a wide range of models, from the smallest fanless desk solution like this one, up to the big chassis-based models with the performance measured in terabits per second. Medium-scale NAT solutions can be implemented using Juniper SRX branch series models like 380 or 550, and data center series models like 1500, 1600 or a virtual SRX. For this type of solution, chassis cluster and 10G speed interfaces are options for consideration. I will start with briefly discussing technology basics, then we'll go over 3 design solutions, and finally I will show you a lab demo with the hands-on and the configuration samples. Let's start with some basics. The whole range of IP addresses can be separated into public address space and private address space. Public address space is the routable in the internet address space, which is being registered and owned by different companies and internet service providers, while private address space is a dedicated address space which is allowed to use for everybody in order to conserve the public address space. But there is a catch, so private address space is not publicly internet routable, and if hosts with the private addresses needs to communicate to the internet, this needs to be translated. This is called the Source NAT, or network address translation. So this is the whole topic of conversation in this video. And also public address space can be separated into portable and non-portable. Again, as I mentioned, public is very similar to like car license plates, which are dedicated and reserved and registered to certain companies. Portable address space, this is when company is using the address space which it owns, which belongs to her. And non-portable is something different, is like renting, for example, a public address space from an ISP, like a subnet from the internet service provider. In this case, you have certain restrictions how you can use this address space. This is just a general topology diagram for like internet, which consists of different networks, private and public, but the internet itself talks only on the public addresses. It means the green networks can communicate via green links because they are publicly routable. All the brown bubbles needs to be translated by some device, which is usually a firewall, and this process, when private address is being translated to public address, is called the network address translation or source address network translation. Port overloading factor. This is a setting which can be applied for the interface NAT or for a certain pool, and it affects how pool is utilized and how scalable the pool is. Let's say we will set at the example of just one IP address. If you don't use port overloading factor, which equals it set to 1 by default, you have a general pool containing all the available ports for your translations. And when the session is being ready to being established, it just takes one address from the pool and being translated. And the example, if the port overloading factor is set to 4, this is when there are basically 4 copies or 4 subpools are created containing all the available ports for that one IP address in this example. And then there is also additional step in the process by doing the certain hash operation on the destination address and selecting which pool this specific session will be using a port from. And basically, it gives us the possibility to increase the potential pool size by not increasing the IP addresses in the pool itself. And as a result, at the same time, there can be multiple sessions using the same port for translation. And every single session will always, based on the hash algorithm, will always hit just one of these pools, not multiple. And you can also influence the number of these pools, which can be set by this factor. It can be from 2 to 32. Let's look into the pool depletion scenario, because there is important and there is a difference here between the two approaches. The first approach is very simple. If all the pool ports are shared, it means as soon as they are depleted, the session is dropped and no more sessions can be established. But in case of the overloading factor use case, remember the hash algorithm. So different sessions are being hashed to a different subpool. And if you have high utilization on one of the pools, let's say one pool is depleted, all the sessions which are based on the hash algorithm are hitting this pool will be dropped. The sessions will not be using ports from other subpools, even if there are available ports still there. So this is something to remember. So how can we scale it? We can. So basically what can be done, if you increase the pool size to 2 addresses from 1, you increase the available port density, right? 2 times, up to 124,000. And it basically will be in every subpool. Increase will be in every subpool, so which is great. But there is a catch. The maximum interfaces in the pool with a non-default overloading factor depends on the Juniper SRX model. And on the branch series or the virtual product, it is limited to 1. In the data center product, it starts increasing. Like in 1500, you can create a pool of 2 addresses and apply non-standard factor to it. Or big boxes like ISP and data center scaling, they can do up to 128 addresses. And there are actually fun facts. A pool of 128 addresses can give you potentially just shy of 8 million sessions for NAT translation. But if you have, let's say, SRX 4600 with the same pool of 128 addresses, but with the port overload factor enabled to 32, the maximum value, you have a theoretical pool size of over 255 million sessions. This is something very important for the ISP scenarios like carrier-grade NAT or CGNAT. On this slide, we can see a lab topology. In this series, there will be 3 videos focusing different type of scaling in terms of Source NAT deployments. This video specifically targets the medium scale, which can be a campus or a branch office. And we'll have a look. The example is here on the left side of the diagram. In the middle, there are routers simulating internet. There is a test internet server which will be sending traffic to. The whole topology is based on Juniper Virtual SRX and Virtual MX products with the versions mentioned here. So let's continue. Next, we'll talk about campus or medium scale use case scenario 1. What if the small use case is not a good fit anymore? You need more bigger pool size. So what can be done? Usually, again, as I mentioned before, there is some kind of subnet provided by the ISP, and which your public address, your outgoing IP address, is set to. There is an option to negotiate with the provider and rent one more address from the same space, right? It gives us this scenario. We can create a pool containing 2 addresses, one interface address and another random address from the same pool. So it will give us totally 2 addresses, which will give us 124,000 sessions as in a pool size. We don't use port overload factor in this scenario. So we'll start with the configuration review. Again, I'll just show it completely and then just go over it with you. So in our case, we'll start here in the bottom. So we can see our link to ISP is the port interface GE000, and you can see the IP address which is assigned on that interface. And then you can also notice that we add this same IP address to the pool, right? By saving the IP address, because remember that 3 is an extra address we obtained from the provider subnet. In this case, we are able to create a pool consisting of 2 IP addresses. So, and then another important piece that our device will be answering for that one because its own address, but for that 3 it won't, right? It requires additional configuration, which is configured under NAT proxy ARP configuration for a certain interface and for a certain address. It means it will start answering ARP for that IP address, and it will accept communication to it, right? This is a mandatory step if you would like to enable additional interface from the subnet. And then the difference is we also have a single rule set, simple, mentioning from certain zone to certain zone, but our action is changed now. So our action is now pool, net pool. So we're basically using not the interface, we are using pool. Probably a few more notes. There is also an interesting and important configuration which I suggest you using, is a pool utilization alarm. So it basically monitors your pool utilization, and if it is raising above a certain percentage, it is sending an SNMP trap message. And also it basically clears as soon as you go below the clear threshold value. So let's keep going. Show security net source summary. Right? So what it gives us, again, it gives us the highlight. It shows us that we have a pool consisting of 2 addresses. We do use port translation, right? And also from what zone to what zone it is applied. So next step will be, another interesting thing from this output when you do summary, it actually gives you this total port number usage for translation. So it basically gives you your total available ports for the translation from all your pools. But keep in mind that this range includes the twin port range, which I mentioned in the presentation, which again are dedicated for certain protocols. So it will be a little lower for the general traffic. So next step is we start similar test traffic. We start ICMP ping from one host that is successful, and from another host we start TCP ping. Continuous. Yep, it's successful as well. Yep. So let's go over here, and then our next step will be show security flow session. Okay, so in this case again we can see our TCP coming from host 2 as well as ICMP coming from host 1. Then we verify across, so our private address was translated to public, and in the TCP case our private was translated to public. So the next interesting thing that remember we have two IP addresses in the pool, and you can see that basically we use 1, we use 3, 1, 3. So basically it is using like something similar to like round robin, and it is using them equally. So all interfaces are used equally, not one after another, simultaneously at the same time. So next step is show security net source pool. Now we have a pool, right? Compared to the interface to the previous solution, now we have a pool. It shows us the pool. It shows us the port range, as I mentioned before. So this is for the general traffic, and this range is for the twin port. So, and then it also shows us the real-time utilization. So this is basically we already use, at the moment, we use 3 ports from this interface, and we use 4 ports from that interface. And this gives us the total utilization in the pool. And it gives you also a separate statistics for the twin port usage. And I can basically refresh, and you can see that it is being updated in real time. The next command will be show security net resource usage source pool, and then we mention our pool name. So this is quite interesting command. It gives you all the details about the pool, including port overload factor, which we don't use at this scenario, right? It gives you the total ports for the pool. It gives you how many used. So this is super useful statistics, including per per IP address. Next, continue with campus medium scale scenario 2. In this scenario, we also consider renting additional IP address, public IP address from the ISP facing subnet. But in this case, we'll do it a little bit different. We can create a pool containing of 1 or 2 addresses depending on the model of the SRX you have, and then use port overloading factor to set to 4. In this case, we have around 250,000 or 500,000 sessions for our pool size. Let's have a look at the lab demo. So let's start with the configuration review. So in this case, we use just a single IP address in the pool. We don't use our provider-facing interface, which is that one, because we use an IP address from the same pool, but which is not assigned to our interface. We have to use proxy ARP, which we do right here. We still use then Source NAT pool, right? And another difference is that we are using port overload factor inside the pool configuration, right? So let's have a look. Show security net source summary, right? So we have we see our pool. We see the total port number for the translation pool, which is around 260,000. And we have single IP address. Remember, we multiplied times 4 because we use port overloading factor. So it is calculated right here. So we have one address and we have our rule over here, details. So the next step, again, we start similar traffic, ICMP ping, which is successful, and TCP ping. Then we go over here back to the device and we do show security flow session. We see our TCP, we see ICMP, right? So again, we check, verify cross the private translated to public, which is .3, correct. Our private ICMP translated to public. So it works as expected. So next step is show security net source pool all. So in this case, we can see the details of the pool. So we need to pay attention to port overloading, right? And also we see the high level real-time statistics of the pool utilization, right? So the next step is show security net resource usage, source pool, and the name of the pool. So this is where the magic happens. So it gives us the idea, the name of the pool, our current overloading factor, our total ports, right? Our current usage, our peak usage. And then it basically shows us our 4 subpools, or like clone pools, right? And each of the subpools, it has available the total amount of ports which are available for a single IP address, each one of them. And then we can, by using this command, we can verify and also monitor the usage of subpools per subpool, right? So we can also see some kind of early signs of going over, right? Or if one of the subpools is experiencing, let's say, depletion. So we have an option to monitor it right here. Basically, that's it. Next is campus medium scale scenario 3. In scenario 3, we consider renting a non-portable public pool from our ISP. As I mentioned, non-portable is a piece of the public address space belonging to a third party, like an ISP. We can use this address for our discretion. The ISP usually creates a static route pointing to us for that route. But there is very interesting thing here. You remember I told before about these 2 special addresses in the pool which are reserved for and cannot be used for the hosts, right? There is a different story with a certain pool which we can use for the network address translation. If we don't set this subnet on any links in our network, we don't set it on the interfaces, we don't set it on the loopback, it just basically just like hanging in the air, as I say. In this case, the port, the IP address number 1 and the IP address in the end, they are still usable. So it means we can use all 4 addresses for our pool. We don't lose any addresses. We can use it in 100% efficiency. In this case, again, very similar routing is still static, non-redundant for forwarding because we have single ISP. But in this case, we consider pool of 4 individual addresses, non-portable, and our total sessions with the overloading factor set to 1, which is a default, around 250,000 sessions. Let's have a look at the lab demo. Let's start with the verifying configuration. So in this case, we create a non-portable pool with the 4 addresses of that dedicated non-portable subnet. Remember that again. In this case, this subnet is not applied to any interfaces, which you can see right here. So, and basically it's, again, even on other portions of the network, it is not configured. So that's why we are able to use the first and the last address from the subnet. So making it efficient use up to 100%. We don't need any proxy ARP in this case, again, for the same reason. It's not on our provider-facing subnet. Provider router has a proper static route for that subnet pointing to our router. We are using then Source NAT pool, matching this pool in our net rule. Yep, we don't use port overload factor in this case. So let's keep going with our verification. Show security net source summary. Right? We can see total number of translations already for that pool. We can see our pool consisting of 4 addresses, which it gives you here in the last column. Next step, we'll again start our standard test traffic, ICMP ping, successful, and TCP ping. And then we do show security flow session. Right? So in this case, we are checking the translated address, and we can see that 0, we can see that 3, we can see that 1, we can see that 2. Right on that screen with just a handful of sessions, we can see that all 4 addresses from the pool are being actively used. We can see also that port is being random and is not sequentially chosen. We can see our TCP, we can see ICMP, so it all looks good. So next step will be show security flow, show security net source pool. Oh, this is again statistics for our pool. We don't use port overloading. We have 4 total addresses, and we have current active hits, 7, basically 7 active sessions. Show security net resource usage, source pool, and then we use our name, so which is non-portable pool. And in this case, this output is similar to the previous lab demo, but remember that we don't use port overload factor in this case, and we use total real IP addresses. It gives, again, utilization statistics per address, which you can see, so it is being roughly equally utilized. But there is an interesting difference between this one and the previous scenario. Remember, as I mentioned in the presentation, this is a total pool. So this all 240,000 addresses are being shared in the same for all the sessions. So it means if, let's say, this interface is depleted and completely used, it will just go to another one, right? So because they are all single shared pool. In case of port overloading factor, we have a hashing algorithm which will choose certain subpool, and if that specific subpool is overloaded or depleted, it won't go to another subpool. So this is something to remember. Here we are. Thank you for watching, and I hope you learned something new or useful today. See you in the next video.